Okay, now when going over arc length, so let's say we want to measure the length of a curve, okay? So we'll create some arbitrary curve right here. Okay, and let's assume that we want to approximate the length of this curve okay? And so I'm going to call the hypotenuse of this triangle L sub k, and the changing in this direction will be delta x sub k, and this will be delta y sub k. Okay. Now the length of L sub k, which is just a fragment of an approximation of the line, would equal the square root. Now this is going to be delta x sub k squared plus delta y sub k squared. All right, so it's just a Pythagorean theorem. Okay, but if we wanted to add up all of our approximations of the curve, L would equal the sum, now k which equals 1 to n of all those little segments. So delta x sub k squared plus delta y sub k now squared. Okay, and now if we manipulate this problem a little bit, we could remove a delta x sub k, and this thing would equal the sum k which equals 1 to n of the square root. Okay, now this is going to become 1 plus, I'll write it like this. Let's say delta y sub k divided by delta x sub k. Both of these squared, and now on the outside of the square root, we would have a delta x sub k. And so, from this point of the problem, what we're going to use is actually the mean value theorem, okay? So, the mean value theorem would state that there exists a C such that f prime of C is going to equal f of b to f of b minus f of a divided by b minus a. And so that's the changing in y divided by the changing in x. And so we can say is that by mean value theorem, this thing is going to equal now the sum k which equals 1 to n of the square root of 1 plus, now this is going to be, I'll write it like this, f prime of c sub k squared, and then multiplied by delta x sub k. All right. Okay, so we got this far. And so what this is saying is that if we have these partitions, and they're finite, this is the formula we end up with, okay? But what if we make our partitions infinitely thin, okay? So then we can say, well, what happens if I take the limit as n tends towards infinity of this, okay? So what I mean by that is we've gotten to this portion of the problem, right? And so This is saying, okay, so I've got all of these little triangles beside of here, and I'm adding them all up. And these are so small, I won't be able to draw the hypotenuse. Okay? Well, if I take the limit now as n tends towards infinity of the sum k, which equals 1 to n of the square root of 1 plus f, no, I used parentheses on that one, so let's continue with that. F prime of c sub k squared, and then multiplied by delta x sub k. Okay, so if I made the triangles smaller and smaller and smaller until they all merge together, this is,
I have a question.
hold on one second. This is going to equal the integral from a to b of the square root of 1 plus f, you know what, I'll use parentheses on this one, f prime of x squared dx. Okay, now this formula right here, this is the formula to calculate arc length. Okay.